Hi, we're going to use the binomial theorem to expand some expressions. So let's take a look. Here we're asked to expand three different binomials with different terms and different powers. Now when we expand a binomial, it's important to note that each term in a binomial expansion is made up of three parts. Let's take the general case, x plus y to the power of n, to illustrate my point. We begin with the coefficients of our terms, starting with n choose 0 and going down to n choose n. Next we have descending powers of our first terms. In this case it's x, starting at x to the power of n, going all the way down to x to the power of 0. Finally, each of our terms will have a power of y, beginning with y to the power of 0, going all the way up to y to the power of n. Now you'll notice that x to the power of 0 and y to the power of 0 doesn't have any terms in there because anything to the power of 0 is 1, and so won't be needed to be shown in our expression. Putting them all together, we get a binomial expression that looks similar to this. We're going to use this binomial theorem in order to help us expand our three examples. So let's take a look at A. We begin by writing the coefficients beginning with 12 choose 0 and going down to 12 choose 12. We then put on our powers of x starting at 12, going all the way down to 1. Finally, we finish by putting in our powers of y, starting at 1 and going all the way up to 12. Remember, y to the power of 1 does not go into the first term because the first term would have a y to the power of 0 in it. Putting them all together, we start off with 12 choose 0 times x to the power of 12, and all of our terms in there will end up at 12 choose 12 times y to the power of 12. Now I need to simplify this. All I'm going to do is put my choose notation into my calculator or look at Pascal's triangle in the 12th line and get my coefficients. And this here is the expansion for x plus y to the power of 12. Let's try B now. B is x minus y to the power of 8. And that negative is going to change the way we do our expansion, but only slightly. Before we begin, we rewrite our expression as x plus minus y to the power of 8. That little separation is going to be important so we don't get confused later on with where our negative is going to sit. Here are our 4 steps to using the binomial theorem. Here is the expression that it will end up being our expansion before we simplify. I started off by writing the coefficients from 8 choose 0 all the way down to 8 choose 8. I then put in my descending powers of x and my ascending powers of y. You'll notice that I've got ascending powers of negative y. Every one of those odd powers is going to give us a negative answer. So we'll be alternating between plussing and taking away each of our terms. When I put them all together, I now need to simplify. I need to write my coefficients as numerals, and I need to make sure that my negatives are in the right spot. Here is the expansion for x minus y to the power of 8. Notice that I start off with a negative and then go for a positive for every even term and a takeaway for every odd term of y. And that will continue on all the way. Let's take a look at our final example of 2a minus 3b to the power of 5. Again, we need to make sure that we write it as 2a plus minus 3b to the power of 5. This will be important so we don't get confused with where our negatives are later on. Here is the expansion using the binomial theorem. I started off by writing my coefficients from 5 choose 0 all the way to 5 choose 5. I then put in my powers of 2a to the power of 5, 2a to the power of 4, in descending order. Finally, I have my powers of minus 3b going in ascending order. Putting them all together, I now need to simplify. What I'm going to do in my next line of working out is I'm going to put in my coefficients as their values, and I'm also going to put all my terms, my 2a's and my minus 3b's, and I'm going to simplify those as far as their powers go. Here's what that looks like. I have my coefficients, I have my powers of a, or my powers of 2a, and I have my powers of minus 3b. Note how the negative 3b's alternate between negative 3 and then positive and then negative 27 and then positive and then negative again. Putting them all together now, I finally need to simplify just by multiplying out all of my coefficients. So the expansion of 2a minus 3b to the power of 5 is that expression there. Good luck with using the binomial theorem, and make sure that you separate out your terms within your binomial, especially if there is a negative in between them. Good luck.